Screen is visible, no?
Yeah, it's visible, doctor.
Okay, okay. Okay, so basically today we will see the examples on this FFT, fast Fourier transform. Okay, so basically in FFT what we are doing, we divide the data set into two or more subsets. Okay, until what we divide this till we get the smaller length DFT, that is one DFT. Until we get one DFT, we divide the data set into two or more subsets. Okay, and by combining all the solutions of the data set, uh, we will get the solution of original data set. Okay, so our approach is basically how we do. We divide each data set like this. You can see divide and conquer approach we say. So basically here we do the radix 2 algorithm. So the size of the signal or sequence we first write in terms of 2 to the power. If it is not matching, then we pad zeros in the sequence. Okay, and then we get the form 2 to the power p, let us say. Okay, so uh, like we will first see the flow chart because so this is the, so how many stages are there, so that is depends upon the how what is the length of the sequence. Okay, now let us take the first example. Now this is example 1. So what is asked here, compute the FFT for this sequence. Okay, now this is basically a 4 point sequence, so the length of our sequence is equal to 4. Okay, now this n we write in terms of 2 to the power p, let us say. Okay, so 4 is equal to 2 to the power p, so this p is equal to 2. Therefore, two stages we will need here. Okay, we need two stages, that is we need to work out two stages. Okay, now first draw the flow chart. Okay, so basically how we go uh, towards the stages, like two stages means this is a, let us say I say stage 1, then output of stage 1 is connected as an input to the stage 2. Okay, and here we will get the whatever output we require, that is x of k, and the input is what, x of n, small x of n, it is capital X of k. Okay, so these two stages we will need. Okay, so the smallest subset, like this is, if it is n size DFT I want to calculate, this x of k is n size DFT we want. Now this n is divided into 2 n by 2 subsets. Okay, 2 DFTs. Now in stage 1 basically we will be having, now if we draw the picture like this flowchart algorithm, so first draw the flowchart algorithm. So at the output side I want output as x of 0, capital X of 1, x of 2, x of 3. Okay, now using bit reversal technique I can get the input. Okay, whatever the sequence of input I can guess using the bit reversal technique. Okay, now this is 0 0, I can write like 0 0. This I can write 0 1, this is 1 0, and this is 1 1. If I do the bit reversal here, what will be the input here? So that is 0 0 bit reversal same as 0 0. 0 1 bit reversal will be 1 0. This 1 0 will be 0 1, and this 1 1 will be 1 1. Okay, So at the input sequence, this is small x of 0, small x of 2, this is small x of 1, and this is small x of 3. Correct? Now this DFT we will divide into two n by 2 point DFT. Okay. Now the n by 2 point DFT here, this is n by 2 DFT and this is n by 2 DFT. Now in our case n is equal to 4. Therefore 4 by 2 means 2. So the input to this DFT are the 2. Okay. So this 2 will be the input to the TFT like this. Okay. So x0 and x2 will be input to this. X1 and x3 will be input to this DFT. Then what is the output of this DFT? That is G of 0, G of 1. This is H of 0, H of 1. Okay, even part and odd part we are separating. Even and odd. Okay. Then how to calculate X of 0? I will say X of k is nothing but G of k plus W and k into H of k. Correct? So this X of 0 is this is summation block, this is summation block plus H of 0 times W and k. Okay, similarly, X of 1 is this plus, now this is for k equal to 0, then I can write W and 0. Here I can write W and 1. Okay, now we have seen the butterfly structure here. So butterfly structure, you can see here everywhere butterfly structure is followed. Okay, like this you will see, like this structure. Just a sec. Okay, so this is called as butterfly structure. For second it is like this. Okay, now how to compute this butterfly structure? So this is the formula for this butterfly structure. Okay, in the simplest way, this is the formula. Okay, so this is our butterfly structure, I will say. Okay, now if you simplify this, so this x of p and x of q is nothing but what? This x of p is this plus omega nr times this. Okay, and this term is always minus 1. Why this is minus 1? So we have done this calculation. This is basically wn n by 2. If you solve this, so you will get minus 1 here. Okay, therefore this is always minus 1. Okay, please follow the steps here. So this butterfly, I will say this is minus 1, this is minus 1, and we will complete this structure, butterfly structure. So the first butterfly will go from this to this. Okay, so I will draw this. So x of 2 is what? X of 2 is, because this is periodic with respect to n by 2. Therefore, this is nothing but G of 0. This minus 1 will come, minus 1 times here H of 0 into W and 3. Okay, same for this second one. This is like Wn4 times H of 1 minus of this plus G of 1. Like this we will calculate X of 3. Okay, so making of this structure is very important. This is our second stage. Okay. Then first stage, how we compute DFT, n by 2 DFT here, how we get G of 0 and G of 1. So for that, again, we need to draw this structure. So basically, we will start with this 2-point DFT. Mm, just a second. So we can see here, we will basically start with this 2-point DFT. Okay. So if I'm having for 4-point DFT, this will be the simplified structure. Okay. This is for 8-point DFT. So first we will draw for our example. Okay. So this stage 1, I can draw like this. Butterfly I need to draw. So I'm having the input x of 0 here, x of 2, x of 1, x of 3. Okay. What I'm getting here, basically I'm getting 0, 1, G0, G1, H0, H1. Okay. Now this is always minus 1. Okay. Now this term is this plus this is W n by 2 of 0. Okay, so this G of 0 is basically x of 0 plus x of 2 times W n by 2 0. How we got this? From this. Okay, this is for n structure, so I have here Wn of 0. Similarly, this is basically multiplied with Wn by 2 0. This term is basically x of 0 plus minus 1 times x of 2. Okay, so we will proceed from stage 1. This is our stage 1. Okay, so first we will do the calculation for stage 1. So minus 1 times, here we should add actually. This W not n by 2 should be here. W not n by 2. This is multiply with this. Okay. So what is the input sequence we are having? So we are having x of n is equal to 0, 1, 2, 3. This is given sequence. Okay. So first we will do the stage 1. Okay. So the simplest thing here to draw the flow chart. Okay. So draw the flow chart for stage 1 like this butterfly structure. Okay. So stage 1 will always be like this. So from smallest DFT, we will go towards the higher DFTs. Okay. So this is equal to what? X of 0 equal to 0. X of 2 is 2. X of 1 is 1. X of 2, this is 3. X of 3 is 3. Correct? This is the given sequence. Okay. Now this is always minus 1 here. Okay. And the Tweedle factor basically comes here. Okay, here. So what is the Tweedle factor needed here? Wn by 2 to the power 0. Wn by 2 to the power 0. Okay. So in calculation part, find Wn by 2 to the power 0. Can you give me the value for Wn by 2 to the power 0? Yes. E to the power minus j 2 pi by n by 2 into what? Into 0. So this is equal to 1. Okay. Now for stage 1, calculate this value. This value is what? This value is basically this 0, addition of this 0 plus this value is 1. So 0 plus 2 into 1, that is equal to 2. Can you give me the value here? How much it is? The second value, how you will calculate? This
Uh,
0 plus this times this minus of this time this. Okay. So how much it is? Yes. Are you following or not? Yes, students. How much it
doc-
is?
Doctor,
Mm-hmm.
can you, wait,
Sorry. Sorry. This is 0 minus 1 times 0 plus minus 1 times what? 2 into 1. So therefore 0 minus 2. So this is minus 2. Similarly, can you give me value here, here and here? What is the value here?
Doctor,
Hmm?
can I ask one question?
Yes.
Uh, why at the x x2 we need to 2 times 1 again?
What? X2?
Yeah, the x2 part,
Hmm.
0 plus minus 1 and times times 2 times 1. Is it
Oh,
like
this
that?
part. This part you are
Yeah,
saying.
I,
Okay.
I don't quite get it.
Okay. So here, what is the output? What you will get? This is the value here is basically this x2
What?
times this wn by 2 0. Okay. So the value here 2 into 1, right? Which is equal to 2. Again, this is multiply by this minus 1 factor. This minus 1 factor. Are you getting the idea?
Okay, doctor, I think I get it.
Hmm. So, and then we are adding here. This is basically the summation block. So what terms we are adding? We are adding two terms. One is this term and second is this term, whatever output is at this end. Okay. So at this end, first end, it is straightforward. It is the this value. Okay. And at the second end, this is basically multiply by this term. Okay. And then you need to again multiply by factor minus 1 Therefore, you will get here 0 minus 2, that is minus 2. Okay, now can you give me value here?
Okay.
Here, how much it is?
Is it 4, doctor?
1 plus 3 times 1 is equal to 4, correct. And the second value?
Negative 2.
1 minus 3 into 1, correct? That is minus 2. Yes, it is correct. Okay. Now, this is the output of stage 1. What is the output of stage 1? 2, minus 2, 4, and minus 2. So, this we will use as an input to the stage 2. Okay. So, stage 2. So, we are having input to the stage 2 is 2, minus 2, 4, and minus 2. 2, minus 2, 4, and minus 2. Okay. For the stage 2, we will be having structure like this. Okay. So we will start with this single DFTs, then we'll go for double DFT, 2-point DFT. Okay. So the butterfly structure will be like this. Okay. So first is draw the structure. So how to draw this structure? So how it will be? So look at this. This is my first butterfly. Okay, and the second butterfly will be like this. Okay, so the first butterfly is basically this. And the second butterfly is this. Okay, now here this is always minus 1. Okay, and the multiplication factor here Wn of 0, this is Wn of 1. Okay, why here it is? So we have seen in the theory, you will see here. Okay, in this PPT. But follow this technique. Now in the calculation part, first thing is calculate the Twiddle factors. So what is the Twiddle factor required here? Wn of 0, Wn of 1. So can you tell me the value of Wn of 0? That is e to the power minus j 2 pi by n into 0. That is equal to 1. Correct? Now Wn of 1, can you give me the value? N is 4 here, k equal to 1. So this is e to the power minus j pi by 2. How much it is? Yes, how much it is?
-1.
Is it minus 1? This is what cos of pi by 2 minus j times sine of pi by 2. Then how much it is? What is cos pi by 2? It is 0. This is 1. This is basically minus j. You forgot j here, right? So I will write the values Wn0 equal to 0, Wn equal to minus j. How can you give me the values here? This is equal to what? This is equal to 2. Oh, this is not 0, it is 1, no? How much it is? 2 plus 4 into 1, correct, which is equal to 6. This value is what? Addition of this plus this into this, add here, okay? So this is equal to minus 2 plus minus 2 into minus j, which is equal to minus 2 plus 2j. Correct? Are you following this? Yes, student?
Yeah, doctor.
Okay, now can you give me the last two values? This is what? This is addition of this plus, or you can directly put minus, minus of multiplication of these two terms. Similarly, this value is this minus multiplication of this. Then what we will get here? This is 2 minus 4 into 1, which is equal to minus 2. And this value is minus 2 minus 2 into minus j, which is equal to minus 2 minus 2j. Okay. So this is our final answer. What is our final answer? Only two stages are required here because this is 4-point DFT. So x of k, I can say my output is, the first value is 6, second is minus 2 plus 2j, third value is minus 2, this is minus 2 minus 2j. Okay, so this is my answer. Okay, answer for this example 1. You can also cross check this answer with the standard DFT formula. That also you can do if you want. Okay, is there any doubt in this?
So far, no, doctor.
Okay, now we will do the 8-point DFT. Okay, now for 8-point DFT, the given sequence is this. Okay, so we know that what will be the output and what is the input to the sequence. Okay, so first thing is, first we want the input. Okay, so how many stages will required here? Can you tell me how many stages will need?
3 stages, doctor.
3 stages, correct. Okay, so this is stage 1, this is stage 2, stage 3. So at the end of stage 3, we will get capital X of 0, capital X of 1, capital X of 2, 3 till what? X of 7, right? Then at the input side, first find the sequence. How we will find the sequence of input points? So with the bit reversal technique, okay. So this is 0 0 0 0 0 1 0 1 0 0 1 1 like this. Okay. So at the input we know that this is X of 0 will be there. If we reverse this bit, 0 0 1 will be 1 0 0. So this is X of 4, correct? This will be X of 2 and this is X of 6. Okay. Similarly, X of 1, X of 5, X of 3, X of 7 is the input sequence required. Okay. So this is given in this flow chart. 0, 4, 2, 6, 1, 5, 3, 7. How we have calculated using bit reversal. Okay. Now we will compute the stage 1. Okay. So stage 1 is basically what? Stage 1 is about the single DFTs. Okay. So first we will draw the structure. So structure is like this. Draw the butterfly structure. This is our stage 1. Okay. So how many butterflies will be there? 4. We will always proceed with this single DFT. Okay. So input is X of 0, X of this is 4. Okay. This is X of 2, X of 6. You write this in a sequence: X of 5, X of 3, X of 7. Okay. And this is always minus 1. Okay. Now the twiddle factor multiplied here is always it is multiplied at this end. Now this is Wn by 4. Earlier it was n by 2. Okay, because there was only 2 stages required. Here third stage is also required. Therefore, this is n by 4. We will go from Wn, Wn by 2, Wn by 4 like this. Okay. So if 3 stages are required, then the twiddle factor is Wn by 4 here. Okay. So Wn by 4 to the power 0 will be required here. Can you give me the value for this? Wn by 4 to the power 0. In calculation, calculate Wn by 4 to the power 0. How much it is? E to the power minus j 2 pi n by 4 into 0. N is it? Everything multiplied by 0, e to the power 0 is 1. Okay. So this is equal to 1. The value of this is equal to 1. Okay. Now, what is the x of 0? What is the given sequence? X of n. X of n given sequence is equal to 21465839. Okay. So map this with the input. So x of 0 is 2. X of 4 is what? 0, 1, 2, 3, 4, 5. X of 2 is 4. X of 6 is what? 3. Correct now? Are you following this? This is 1, 2, 3, 4, 5. This is 8. X of 3 is 6. And x of 7 is 9. Are you clear about this input, how we have mapped?
Yes, doctor.
Okay. Now compute the first stage. Give me the output at the end of stage 1. Yes, what is the output here?
Is it 7, doctor?
This is 2 plus 5, 7, correct. Second value?
-3.
Minus 3. Then this value is
7.
hmm. This value is
1.
1, correct. This value is how much? 1 plus 8, it is 9. This is 1 minus 8 is minus 7. This is 6 plus 9, 15. 6 minus 9 is minus 3. Okay, so this is about stage 1. Now we will proceed to stage 2. So whatever is the output at this stage 1 will be the input to the stage 2. Correct. So we will be having 8 inputs. So draw these 8 lines. Okay. So what is the input here? 7 minus 3, 7, 1. 7 minus 3, 7, 1. 9 minus 7, 15 minus 3. Okay. Now draw the butterfly structure. So how we will draw the butterfly structure? Now this is 1 point DFT. Now this is 2 point. Therefore, this will add to second line. This will go to the second line. Okay. So this is my first butterfly. This is my second butterfly. Butterfly means this is my first butterfly here. And the second one is like this. Okay, so this factor is always minus 1. I said this is minus 1, this is minus 1. Okay, similar structure we will draw for the second part. Okay, so this will go to this, and this will add up to this. Okay, so this is the first butterfly here, and the second one is this. Okay, and the value is minus 1 here always. Okay, now what about the Twiddle factor? This is the second stage. Therefore, Twiddle factor will come here. Okay, so this is Wn by 2 0, Wn by 2 1. This is Wn by 2 0, Wn by 2 1. Okay, so now this is our even part and this is our odd part. Like we have separated this in two part. For the first stage, this is even, this is odd, even, odd, even, odd, like this. Okay, now can you compute values here? Give me the value. How much is the value here? Yes, this is equal to, this is equal to, this is equal to, this is equal to. Give me the first value. For that, you need the calculation. Calculation of Twiddle factor, Wn by 2, 0. Wn by 2, 1. Yes, Wn by 2, 0 is 1. Okay, can you give me the value for Wn by 2, 1? Yes, Wn by 2, 1 is how much? Here n is equal to 8. Yes, how much it is? E to the power minus j 2 pi by n by 2 into 1. E to the power minus j 2 pi by 4. 8 by 2 is 4. E to the power minus j into pi by 2. So earlier we have calculated this value, which is equal to minus j. This is 1, this is minus j. Yes, now give me the value here. Yes, this value is what? This value is addition of this plus 7 into this, multiply and add here. So how much it is?
14.
7 plus 7 into 1, which is equal to 14. Second value, minus 3 plus 1 into minus j. That is minus 3 minus j. Correct? Third value. So like this, you can compute the values. Okay. So I leave it to you to find these values. Okay, now we'll go towards the stage number 3. Stage 3, first draw the flow diagram. So we will need 8 lines here. 1, 2, 3, 4, 5, 6, 7, 8. And what is the structure? Structure is like this. For stage 3, it is like this. Okay. Now you can draw this structure and find out the output. Will you able to do this? Yes, student?
Maybe we can, doctor.
Okay, can you do this at home? Okay, so you do this at home and find out the answer for this. Okay, so at the end of stage 3, we will get x of k value. Okay, now how you will draw the butterfly structure here? So 1, 2, 3, 4. This will go like this. Okay. So first butterfly, how we will draw this, 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 like this. Okay. So you need to draw the structure. Draw the structure carefully. Should be added to this. Okay. Now the first butterfly is this. So this is always -1. I said this is always -1. -1, -1, -1. Okay. And at the end of this, it should be multiply in wn0, wn1, wn2, wn3. Okay. So you should get output. You can check with your calculation. The output you should get at the end of stage 3, that is final value of x of k. I'm writing here x of k is equal to 38, then -5.828 plus j times 6.07 6j, then minus 0.172 plus j times 8.07 minus 10 minus 0.172 plus j times 8.07 minus 6j minus 5.828 minus j times 6.07. This output you should get. Okay, so you can cross check your output. This should be minus, I guess. This is minus. Okay, and there is one more problem. So this is also, you take it as a homework problem. Okay, this is homework for you. And the output, the answer for this, it is given in this flow chart. Okay, so the overall flow chart will be like this. Okay, so similarly you can draw the overall flow chart for 4-point DFT, the first example we have done. So for that also you can draw the flow chart like this. Okay, so here it is stage 1, this is stage 2, this is stage 3. Okay, so you can check here where is omega comes. This is sorry, wn by 4, wn by 4 will come here, wn by 2, n by 2 will come here, 0 1, and wn will come here. Okay, student, we will stop here today. Okay, I will share this PPT with you.
All right, doctor.
Okay,
Okay. Thank you, doctor.
thank you, students.
Thank you, doctor.
If you are not understanding the procedure of FFT, means how we are doing